Assalamualaikum and good morning. Okay, today I will explain about chapter 13 is gas law and kinetic theory. Okay, so this is the lesson 16. The first linear outcome is for subtopic 13.1 ideal gas equation. So the first linear outcome for this 13.1 subtopic is solve the problem related to the ideal gas equation PV equal to nRT, while the second linear outcome is discuss the following graph of an ideal gas, PB graph at a constant temperature, VT graph of the constant pressure, and then pressure temperature graph at a constant volume. So for 13.1 ideal gas equation, what is mean by ideal gas is a perfect gas which obeys the three gas law. So what is the three gas law is? The first is Boyle's law, second is Charles' law, and then the third one is Gay-Lussac or pressure law. So what is happen if the ideal gas is confined to a cylindrical container with a volume with a change of temperature, if a change of temperature, pressure and volume. So we look at the next slide, which is this one. Okay, if the temperature is constant, so we can apply formula PV equal to nRT. So kita tahu temperature is constant, N is number of mole, R is Boltzmann constant, T is constant. So kita akan dapat PV equal to constant. So we rearrange the equation, we get P is inversely proportional to 1 over V. So from this relationship, we know that if T temperature, when V is increasing, your pressure will be decreased. Or if V is decreased, the pressure will increase by using the relationship of P is inversely proportional to 1 over V, and then this is Boyle's law. And then the second one is when the pressure is constant. So we still use formula PV equal to nRT. Okay, so we rearrange the formula first with the which one is constant. So P constant and nR is constant also. So kita akan dapat V is directly proportional to T. Okay, so bila directly proportional, when the temperature is increased, the volume of the container is also increased. And then if the temperature of the container is decreased, and then the volume also decrease. This one we can state that it is a Charles law when the pressure is constant. And then for the third one is for if volume is constant. So PV equal to nRT. Okay, so kita tahu kita punya V dengan nR is constant, so P equal to nRT over V. This is constant. So P is directly proportional to T. If the temperature of the container is increasing, the pressure of this container also increase, or vice versa. So this is can relate to the Gay-Lussac law. Okay, how is the ideal gas law is derived? So, from the Avogadro law state that the volume of a gas is directly proportional to the number of mole. Boyle's law is volume of the gas is inversely proportional to its pressure. I already explained from the previous slide how to get the V is inversely proportional to 1 over P. And then for the Charles law state that the volume of a gas is directly proportional to the Kelvin temperature, so V is directly proportional with temperature. So if we combine this law, we will get V is directly proportional to NT and inversely with the pressure. So disebabkan kita ada constant which is R, so kita akan jadikan proportional into an equality. So we get V equal to nRT over P, and rearrange the equation, you will get PV equal to nRT, where P is pressure, V is volume, N is number of mole, R is Boltzmann constant, T is temperature in Kelvin. Okay, so The equation of state for an ideal gas, PV equal to RT, where N is the number of mole of gas, and then N, how to calculate the number of mole if given mass of gas. So we use this formula, N equal to M over M, capital M. So M, small m is stand for mass of the gas in kilogram, in kNm. Molar mass is M, km, capital M is molar gas of a gas. So, and another formula for number of mole is capital N over Avogadro constant. So, capital N is referred to number of molecules. So, pressure is in unit of Pascal, V is volume in unit of meter cube, and then T is absolute temperature in unit of Kelvin. So where R is the constant is universal gas constant, which is 8.31, and Boltzmann constant is K equal to R over Avogadro number. So K is the constant value 1.38 times 10⁻23 joule per Kelvin. So we can use this both formula, PV equal to nRT or PV equal to capital NK KT. So for graph for an ideal gas, for the first gas is Boyle's law, where PV graph at a constant temperature. So it is stated that the pressure of a fixed mass of gas at a constant temperature is inversely proportional to its volume. So this is the formula when T is constant. So we rearrange jadikan this proportion in equality equation. So V is bring in front, you will get PV equal to 1. So PV equal to constant. So bila PV equal to constant, we can take out the formula we use for P1 V1 equal to P2 V2. We can compare with two container to calculate the pressure of volume. Okay, example. The syringe injection when removing fluid from a syringe or when filling blood in a syringe. Okay, so this is the graph of the Boyle's law. If P is inversely proportional to 1 over V, so bila P is against V, so kita akan dapat graph begini. This one, T2 is greater than T1. If PV is against P, so kita tahu kat sini T1 and T2 is constant with same pressure and volume. And then the third graph is formula of P against 1 over V, we will get straight line. So T2 is greater than T1. And then the last one, PV is against with volume. T1 and T2 is in parallel line. Okay, for the second graph, if VT graph at a constant pressure, which is it is a Charles law. So Charles law states that the volume of a fixed mass of a gas at a constant pressure is directly proportional to its absolute temperature. So this is the formula, V is directly proportional to temperature. So when P is constant, so we arrange the formula until it get equality equation. So V over T equal to constant. So we can use this formula for V1 over T1 equal to V2 over T2, where V1 is for the initial volume, V2 is for the final volume, T1 is for the initial absolute temperature, and the T2 is the final absolute temperature. So the example we can apply for the Charles law is for the hot air balloon. When a gas is heated, temperature is increased, it is expand. When it's expand, maksudnya dia punya volume also increasing. As the expansion of the gas take place, it become less dense and the balloons is lifted in the air. So this is the graph for the Charles law. If volume against temperature in degrees Celsius, so we need to extrapolate the graph until we get 1 degree Celsius equal to negative 273.15 Kelvin. If the formula is volume over temperature in Kelvin, so we will get straight line graph and past origin. And the third graph is pressure temperature graph at a constant volume Gay-Lussac pressure law. So it states that the pressure of a fixed mass of gas at a constant volume is directly proportional to its absolute temperature. So the formula is P in directly proportional to temperature. So V is constant. So rearrange the equation until get equality equation. So P over T equal to constant. So kita akan guna P1 over T1 equal to P2 over T2. So P1 is the initial pressure, P2 is final pressure, T1 is initial absolute temperature, and T2 is final absolute temperature. So the example we can apply for the Gay-Lussac law is a burning automobile tire. When the heat of the temperature, the burning rubber is increase. So kita put air pressure pun increase and cause the weakened tire wall to explode. So this is the graph for the Gay-Lussac law. If the pressure against T in degrees Celsius, we know that we need to extrapolate the graph until we get negative 273.15 degrees Celsius. And then the second graph, if we get the pressure against temperature in Kelvin, so kita akan dapat straight line graph when it reach the origin. Okay.
Hi, Assalamualaikum warahmatullahi. Good morning. So we continue lesson 16 with the second subtopic 13.2 kinetic theory of gases. So for this subtopic we have 4 learning outcome. So we look at the first one. State the assumption of kinetic theory of gases. So for the assumption of kinetic theory of gases, we have 7 assumptions. Okay, ni kena hafal lah. Okay, next, discuss the root mean square or RMS speed of gas molecule. Number 3, solve the problem related to the root mean square of gas molecule. So the last one is solve problem related to the equation. Okay, so now we look at the assumption of kinetic theory of gases. Okay, for kinetic theory of gases, so actually it's explained about the microscopic properties of the gas and it based on the behavior of gas molecule. Okay, we have 7 assumptions. So number 1, all gases are made up of identical atoms or molecule. Number 2, all atom or molecule move randomly and haphazardly. Number 3, the volume of the atoms or molecule is negligible when compared with the volume occupied by the gas. So ni maksudnya dekat sini. So let's say kita ada satu container with volume V, volume dia V. Tapi when we compare with the size and mass of the atom and molecule, size molecule dengan atom tu kan very small. So that's why dekat sini, so the volume of atom or molecule is negligible when compared with the volume occupied by the gas. Sebab size dia very small. Okay, that one for number 3. So assumption number 4. The intermolecular forces are negligible except during collision. Next, number 5. The interatomic or molecular collision are elastic. So maksudnya dekat sini, before and after collision, V dia will be equal. V dia sama before and after. So that, so bila V dia sama, the kinetic energy also same. So bila kinetic energy dia same means kita punya collision is elastic. Okay, next number 6. So the duration of collision is negligible compared with the time span travelling between collision. So atoms tu ada banyak kan? So dia nak travel from point A to point B, dia jauh. Walaupun dia dalam space tu kecil, tapi kita nak compare with the duration of collision. Masa dia collide tu, dia sekejap je. Take. Okay. That's why dekat sini for number 6 they state that the duration of collision is negligible compared with the time spent travelling between collision. Okay, we go to the last assumption. Atoms and molecule move with constant speed. So ingat tak tadi saya kata, so before and after collision video is equal. So dekat sini pun dia state that with constant speed between collision, gravity has no effect on molecular motion. So there is 7 assumption of kinetic theory of gases. Okay, so we continue with the equation of VRMS. So actually we have 4 equations for VRMS. So the first equation we get it from the definition of VRMS yang tadi tu. Other than that, we have another 3 equation for VRMS. So kita tengok dulu, VRMS equal to 3kT over M. Kita tengok ni ya. So PV equal to NKT. So PV also equal to 1 over 3 NMV square. So we equalize these 2 equations. So we get NKT equal to 1 over 3 NMV square. So N and we cancel. So here 3kT over M equal to V square. So we square root the equation. So then we get VRMS equal to 3kT over M. So settle equation ini. So we look at the third equation. VRMS equal to 3RT over M. So V equal to VRMS equal to 3kT over M. M here we refer to the mass of the molecule, small m. Okay, K over M actually equal to R over M. R over molar mass. R is the Rydberg constant. Capital M stand for the molar mass. So we just substitute here. So here we get 3RT over M also equal to VRMS. So we get our third equation for VRMS. Okay, so next is the equation number 4. VRMS equal to 3P over rho. Rho stand for density. Actually, it's come from the equation P equal to 1 over 3 density time with the V square. So, sini kita dapat. So, here is 3P equal to rho V square. So, V square equal to 3P over rho. So, VRMS equal to 3P over rho. Rho is the density of the gas. Okay, so there is 4 equations for VRMS. The first one come from the definition, and another 3 we get it from the derivation of the equation, and we relate with the pressure and also with the Rydberg constant and pressure. Okay, that's all for our second subtopic and the discussion of root mean square of gas molecule. Thank you. Okay, now let's discuss about the root mean square velocity or VRMS of gas molecule. So let's see, so we have n number of molecule. So every of the molecule move with velocity v. So that's why here we label as V1, V2, V3 and so on. So then we find the average speed of the molecule. So kita dapat, so V average dia sama dengan V1 plus V2 plus V and so on when we divide by n number of molecule. Okay, lepas tu the mean square or speed of the gas molecule. So kita dapat V square equal to V1 square plus V2 square plus V3 square. Then we divide by n. That is the mean squares of speed. Next, kita tengok pula the root mean square speed. Okay, apa maksud root mean square speed? So, it's defined as the square root of the mean squares of speed of the individual molecule. So, kita dapat, so tadi kan kita dah ada V mean square tu tadi, then kita square rootkan dia. That is the VRMS. So, yang ini, this is the definition of VRMS.